many loops are there? More than one loop, no? We have to find out current in all the branches in this. So again, I'm going to take help of same. So here, let me assume the direction of flow of current. So here, current in this loop be I1, and the current in this loop be I2. But these are called as a loop currents. Current in this loop be I1, the current in this loop be I2. What is the polarities? The current here will enter positive, negative. The current here will enter positive, negative due to I1. Due to I2, the current will enter and will leave here. Due to I2 across 1 ohm, this will be the convention. Now let's write the loop equation, KVL. Now, how many unknowns are there? I1, I2. We need minimum of 2 equations to solve this. So this will be plus 10. Again, what is the direction of traverse? So how to take direction of traverse? So here the direction of traverse will be, I'll give the name. Let this be A, B, C, D, E, F. So A, B, C, D, A for loop. What do you mean by this A, B, C, D? Direction of traverse. So I'll move now from A to B. Rise in EMF or fall in EMF. Rise in EMF plus 10. Then I'll move from B to C, fall in drop minus 2I1. Then across this resistor, 2 currents are there, I1 and I2. 2 loop currents are flowing. So this should be minus 3I1 due to fall in drop of I1. Then the current I2 also will flow from C to D. So due to that, it will be 3I2 equal to 0. Close path. So what is the path? The path I took like this. Plus 10, try to see. Then minus 2I1. So what is the current? It will flow here, I1. This I1 is a loop current. Then come for here. Here in this branch, both the currents will flow. Current due to I1 and also current due to I2. So what is the resultant current here? I1 plus I2. So therefore for individual, minus 3I1, minus 3I2. All set again equal to 0. Where I started at A, I'll end up at A. That one. So this equation will be 10 minus 5I1, 3I2 equals 0. So similarly, we'll write loop FECD. Now what is the equation? Plus 6 minus I2 minus 3I2 minus 3I1 equal to 0. Now the traverse is like this. Plus 6 minus I2. Here minus 3I2 minus 3I1. So this will become equal to 6 minus 4I2 minus 3I1 equals 0. How many unknowns are there? 2 equations, 2 unknowns. Solving 1 and 2 will get the required answer. I'll multiply 4. So this will become 40 minus 20I1. 3 I should multiply, no?
2 and 0, sir.
Anybody value I1, I2?
2 and 0.
2 ampere, 0.
Yes, sir.
2 it will be. Yeah. Okay, fine. I'll do one thing. I'll change value a little bit because I2 0 again. There's a first problem. No, you will be under wrong impression. Let me change this. Because again, you'll start thinking every time I2 will be 0. Need not. Anybody value this? I changed value, EMF of second cell. Values of I1 and I2.
26 by 11 and minus 10 by 11, sir.
26 by 11 minus 10 by 11.
Yes, sir.
Okay, now really some good information. We wanted that negative sign also. Look at this. I1 is this much, no? And look at I2. I got I1 positive. Okay, fine. I assumed in that direction. What about I2? I2 I got negative. What does it mean? Actually, the loop current will not flow anti-clockwise. It will in fact, it will flow in clockwise. The actual currents will be the actual currents what we assume, no?
Sir, it is 16 by 11 and 10 by 11, sir.
Sure. Huh?
Yes, sir. I checked, like I substituted.
Oh. Give me exact values because based on that I have to interpret.
Yes, it's coming 16 by 11, I1.
16 by 11. Yeah.
Plus 10 by 11.
Plus. Yeah. Okay, I got both positive. Okay, it's fine. Like this, these are the current signs. So what is the current in each branch? Let's get the branch currents now. This is 10 volt, 8 volt, this is 3 ohm, this 1 ohm, and this 2 ohm. So what is the current here? How much of current account to this? I1 16 by 11 ampere. So 16 by 11 ampere. How much of current here? 10 by 11 ampere. How much of total current? I1 plus I2, 26 by 11 ampere will flow because there is a common branch, no? Where both the loop currents you have to add up here. So again, the polarity will give like this. This is a polarity. Plus, minus, plus, minus. After this, I'm further one very important one. I want potential difference VBE. This potential difference I want. So I'll start with the KVL. So earlier I applied KVL. Like this also I can find out potential difference between any 2 points in a circuit. After getting loop current, what are I1, I2? You have to call them as loop currents. What they are? They are loop currents. From loop currents, what you can get the branch currents. What is the current in branch CD? Sum of both I1 plus I2. Okay, I want potential difference VB. I'll start like this. Where I begin, there should be positive. Similar to manometric equation. What earlier we had, no? Similar to manometric equation it is. Plus where I begin positive, then minus high R, so this will be 16 by 11 into 2 minus, so I'll move from positive to negative, no? Then plus 10 by 11 into 1 minus VE equal to 0. So therefore VB minus V should be equal to 32 by 11 minus 10 by 11. So this should be equal to how much? 22 by 11 or 2 volt. What I did, you can see that one. I started from here. Where I begin positive VB minus 16 by 11 into 2 IR drop. Why negative? Because I'm moving from IR to lower potential. Then I'm moving from low to higher potential plus IR drop minus where I end up negative. So when you can write now potential difference between any 2 points, you can see the equation. I got 2 volt. You can ask question, sir, is it right?
Sir, why are you equating that to 0?
Algebraic sum of EMFs should be equal to higher drops in a closed path. It's like a linear equation, no?
Sir, there are 2 cells also that you did not consider in that
Okay,
closed path.
I'll do one thing. So you didn't like this path, no? I'll move. This is for path BCE. Now for path BADF, we'll write it. Path BADF. I can come by any path, no? I should get same answer. Then only all mathematics assumption, everything is correct here. So for path BADFE.
Sir, BC is not a closed path.
Wait. Let me finish off. In the end, you can ask all the things. Let me finish off. No. So at point B, I'll start it. VB minus 10 plus 8 minus V 0. So this should be 10 minus 8, 2 volt. So what is the path? Path, I went like this. VB minus 10. Then you see this here. Plus 8 minus V 0. How much I got answer? The same 2 volt, no? The same answers I got. VB earlier, how much it was? The same VB. So this shows that what all our mathematics, what all we assumed, everything is correct here. No, see, closed path doesn't mean that the physical one. It's a wrong idea. Because we will measure this VB, some voltmeter, no? That instrumental, when I connect it, will become closed path. This VB, we will measure this, some instrument. And where do I connect? I'll connect across B and D. So definitely that instrument and this branch BC will become closed path. Okay, fine.
Sure.
Why it should be equal to 0? Because the law says the algebraic sum of EMFs should be equal to algebraic sum of IR drops. That IR drops, if you bring on to LHS, should be equal to 0, no? Yeah.
So in path PADFE, why shouldn't we write VA, VD, VF?
Path, I'm not getting.
PADFE.
PADFE. Yeah, because only cells are there, no, in my path.
You're starting from A, sir.
I'm starting from P. I'm starting from oh, this B, no, it is. Yeah. I'm starting from B, you see. Because I want potential diff and VB, no, I can choose any path. So one student will pick up this, you will get 2 volt. Other student will choose some other path, you will get same answer. This is something very important here. How to calculate potential between any 2 points? You just where you begin positive, where you end up negative. In between, if you move from positive to negative across the resistor, fall in drop. If you move from negative to positive, rise in drop. If in between, if you move across any cell, so apply rise in drop and fall in drop. And like that, you can determine potential difference now between any 2 points in a circuit. I want VCD. You can choose any path. You'll get the same answer. I'll start like this.
Sir, can you explain again why potential T is negative, sir?
Why potential?
At E is negative. We took minus V, no, sir.
No, there's a manometric equation like where you end up, where you begin positive, where you end up should be negative. No, there is a convention.
Okay, sir.
For path CD. So what you write it? VC minus 26 by 11 into 3 minus VD equal 0. So our VCD should be equal to how much? 26 into 3, 1678 by 11 ampere. Okay, now some other student will pick up some other path here.
Not ampere, sir.
Volt, sir.
Sorry, this is volt. Now other student, what happen? You will pick up a path like this. Path C, B, A, D. So VC plus 16 by 11 into 2 minus 10 minus VD 0. You solve it, you'll end up with same answer. So what are the path? One path will be like this, VCD. What is the other path? VC minus 2 into minus IR drop here. Why? Because plus IR drop. Why? Because I'm moving from low to higher potential. Then fall in EMF from positive to negative terminal, minus 10, minus Vd equal to 0. You can pick up other path like a V, E, F, D. Again, you'll get the same answer. Okay, this is a very important. Getting potential difference is very, very important. Last one, path C, E, F, D. So this should be equal to Vc plus 10 by 11 into 1 minus 8 minus Vd 0. You'll get same answer. Okay, fine. So like this, if you get one loop or two loop, KCL, KVL, are they series or parallel? We are not very sure. That's why we took help of KVL. If they're series parallel, directly take help of series parallel. If they're not series parallel, write KCL, KVL and solve it. Let me discuss some series parallel problems.